right? So last time we covered the all the rules, right? Starting from same base, same exponent, zero exponent, and negative exponent. Today we're introducing a new rule for the exponents. Is what happens if the exponent is a fraction. For example, like 1/2, right? What does it do? 1/2 is same as 0.5, right? So if you see a decimal exponent, change it to fraction. Okay, then we can apply the new law, right? So let's look at this one. What is the value of 25 to the half? Okay, so this is what we are going to figure out here, right? 1/2. So first, we'll copy down here. Okay, we'll find a way to figure out what it equals. So 25, if I want to write 25 using some exponent, I can rewrite it as 5 squared, right? The 1/2, I'll write it as red. So that means the whole thing to the half, right? I did not change anything here. I just rewrite it. So the left side is still the same as the right side, right? 25, I rewrote it as 5 squared. Okay, so now you have two exponents next to each other. So what do you think we can do to simplify this now? Harry? Harry?
I don't know.
Yes, you do know, because you did your homework. You have two exponents here, right? You have a 2. You have a half. They are both exponents. So what can we?
Multiply it in.
Yeah, that's right, right? You did that for your homework, right? It's the, I think it was what? The third rule, right? So what would it become?
5 to the power of 1.
Yeah, 2 times a half. Okay, I'll write it slowly. 2 times a half will become 5 to the 1. 5 to the 1 is same as 5. Okay, so 25 to the half, it becomes 5. So what kind of things is happening here? Why does having a half as an exponent can make 25 become a 5? Amanda, what do you think? What does it do?
I don't know.
How do you make a 25 and then become a 5? What kind
Square
of,
root.
yeah, square root, right? So having an exponent of half is like placing a square root on the number, right? It does the same thing. Okay, let me move this up. Okay, so from this example, we can sort of guessing, right? Oh, half can do that. So that means the next time, okay, if you see, for example, like 36 to the half, this will mean square root of 36, right? So that will give you a 6. So when you see a half, it means square root. Okay? So also if you see like decimals, right? Let's say 49. 49. To the negative 0.5. Okay, how do I do 49 to the negative 0.5? Marcus, what do you think? How do we begin?
Square root of 49.
Close, but there's a
Um,
negative, right? What do we do?
uh, you want to make it positive?
Yeah, how do I make negative exponent become positive?
Uh, the fraction,
Yeah.
isn't it like 1 over like 49, 0.5?
Yes, perfect. Okay. So negative, you use your knowledge from last week, right? Make it move it to the other side. And then the 0.5 is same as half. So it's like 49 to the half, right? I'm doing very slowly, okay? Showing every step. And then the half, you know, it's a represents square root, right? So your final answer should be what, Marcus?
7.
7?
Uh, uh,
Did you forgetting something?
over 1 over 7.
Yeah, 1 over 7, right? The 7 is in the denominator, just like the 49 is in denominator, okay? So these are 3 examples, right? Using the half. So it could be, the question could be in decimal, could be combining with negative, right? So what you learned before, it can be mixed up here, right? Mixed together. Right, so what if it's not 1 over 2, right? What if it's something else? Like 2 to the 5 over 3 on the right side, okay? So if it's 1 over 2, it represents square root. So the 2 is like the square root, right? 2 represents it's a square root. Let me write it on the outside. Okay, give me 1 sec, okay? Okay, so if you have square root of 25, the 2 in the denominator, the 1 over 2, the 2 is like the index, it's square root. Okay, let me circle that. Okay, so if you see a 1 over 3, it would represent the cube root. Okay, so for example, let's do that on the side. Okay, do the same thing on the side. So first, let's say we have 8 to the 1/3. Right, compare with what we did on the left side. 8, I can rewrite it as what? What's another way to rewrite the 8? I'll use the red for 1 over 3. Okay, so 8. Chris, how do we rewrite the 8?
It would be 8. It would be 2 to the power of 3.
Yes, very good. Okay, 2 to the 3. Right, similar to the 25. 25, I rewrote it as 5 squared, right? 8, I can rewrite it as 2 to the 3. Outside, you have a 1 over 3. So what can we do? Harry, now, what do we do?
Multiply it in.
Yeah, what do you get?
2 to the power of 1.
Yeah, 2 to the power 1. Once again, it's the same as just 2. So the same thing, similar happened, right? 1/3 to make the 8 become a 2. The only thing that could also do the same thing is the cube root. Right? Cube root of 8 will also give you 2. So from this example, you know that if it's 1 over 2, it's a square root. If it's a 1 over 3, it's a cube root, right? So the denominator represents the kind of root that you can have. So now if we combine with something else. Let's say we look at the question now, the 2 to the 5 over 3, okay? So example 2, 2 to the 5 over 3. I can think of it as two things happening. I can have a 2 to the 1 over 3 times it by 5, right? I can split the 5 over 3 into 1 over 3 times 5 over 1, right? It's the same as written like that. So 2 to the 1/3 we know as a cube root. Okay? So I'll use the red, right? Over 3, 1 over 3, 5 over 3. Okay? And then 1 over 3 become the cube root. So the 5 is outside. Okay, so take a look, right? 5 over 3, it means having a cube root with a 5 on the outside. Same meaning, okay? Or I can split it with a different order. I can do 2 to the 5 to the 1/3. It's the same, right? Because they're multiplying. I can have the 5 on the inside or 5 on the outside. But the way it looks different is the radical will be outside now. It'll be 2 to the 5 first, and then outside you have a cube root. So bracket is around the 2 to the 5. Okay, so please compare these two. Both of them are same questions, right? But the way it means is different. Answer is the same, okay? But then the way you write it out is different. So both are correct, but I would prefer the second way. Later I'll explain why, okay? Why I prefer the second. Let me see. Actually, the first way, okay? Wrong one, third way. Okay, later when we do the questions, I'll explain why the first way is better. Having the root first, okay? So this one is preferred. If we are just changing into the radical form, okay, you can do either ways. But later when we want to evaluate, the first way is better, okay? So here, writing out like this, okay, I don't want to make it too messy, okay? This way is called the radical form. Right, you have the radical sign, right? Square root, cube root, those are called radical form. Writing out this way is called the exponential form. Okay, so I give you some time to write all these down. Okay, make sure you have a good notes so you can refer back, right? You don't need to keep looking at the video, right? You can just study the notes. Okay, you can raise your hand once you are ready to try some questions together. Okay, please raise your hand if you finished writing all the notes and ready to move on. Okay, Brandon and Ivy, you still copying or? Brandon, Ivy, are you there? Hmm? Okay. And Ivy, are you there, Ivy? Ivy, are you there? Ivy, are you away? Or I need to call you? Ivy. Okay, give me 1 sec. Okay, let's try the following 4 questions, okay? So here we want to evaluate each of the fraction exponents, okay? So some of them you cannot evaluate because it's not a perfect square or cube. You just write it out in radical form, okay? So first thing is to turn them all into radical form. So I'll let you guys try it out. Question C, you can see there's a negative, right? Question D also has a negative. So think about what negative exponent does, okay? So I'll let you guys all try it first. Write down what you think it will become, and then we'll go over the answers together, okay? Ivy, are you back? Ivy, are you there? Okay, once you guys finish these 4, you can raise your hand, okay? Turn them into radical form, okay? And if you can evaluate, then evaluate. Okay, so seems like Ivy has some connection problem. Ivy, are you there? Can you hear me?
Yeah.
Oh, you're back. Okay, okay. Okay, yeah. Because everyone else was raising their hand, only you didn't. So yeah, it's
Oh,
okay. Yeah.
okay.
So let's go over A, B, C, D. Okay, so far we got Elaine finish these 4. Okay, just write down what you think it looks like. Doesn't matter if you think it's not correct. Everybody try it, okay? Just turn it into radical form. You can raise your hand, okay, when you're done. Only one person done. Shouldn't take that long. Right, just change it to radical form, okay? That's all. If there's a negative exponent, move it to the other side. Okay, let's check your answers. Okay, Colin, what do you have for A?
I just did this. It's the square root of 3.
Yeah, square root of 3. That's good. Okay, that's all you need to do, right? Because square root of 3, it's not a perfect square, right? It's not like square root of 25. You can do more. You just leave it, okay? That's all you do. Okay, question B. Evan, what did you put?
I put a bracket, square root of 4 inside the bracket to the power 3.
Yeah, very good. Okay, and is that all you did? Anything else you did after that?
No, I just left it like that.
Okay, so if we want to evaluate, right? Evaluate means you want to simplify more and more as far as you can. So what do you think, what else we can do after that? Anyone else did something more than this? Angela?
Wait, could you square root the 4?
Oh yeah, we could, right? So what would that become?
Just 2 to the power 3 in bracket.
Okay. Yeah, 2 to the power 3. And then can we do something more? What else can we do? What's the 2 to the 3? Evan?
Oh,
Hmm? 2 to
I'm
the
not quite.
huh?
Oh, it's 8. Oh, sorry, it's 8.
Yes, okay. Yeah, 2 to the 3 is 8, right? 2 times 2 times 2. So depending what the question wants, this is very important, okay? Because in the homework, the instruction is important. If they say evaluate, right? You see I highlight that. Evaluate, then you go as far as you can. This is called evaluate. You leave your answer like that. If the question says, please write it in radical form, then you leave your answer just in the first way, radical form. Okay? So two different answers depending on what the question wants. Even though I say this many times, it's still keep writing, leaving the answer in the wrong way. Okay? So if they say leave it in radical form, you do not need to evaluate. Okay? If they say evaluate, do not stop at the radical form. Okay? In question A, there's nothing else to do, right? So both evaluate and radical form look the same, okay? That's as far as you can go. Okay, are we clear about the difference between evaluate and radical form? Okay, so make sure you read the instructions when you are doing the homework. Question C. Okay, Jenny, what's your answer look like?
I have 1 over the radical form, but it's a 3, 27 to the power of 2.
Oh, so you can call that cube root.
Okay,
Okay, so cube root 27 and then
to the power of 2.
yeah, to the power of 2. Okay. Did you do anything else after that, Jenny?
No, I wasn't sure where to go from there, or if I could keep going, so
Yeah.
I just left it.
Okay, okay. Anyone else want to add to that? Anyone else did different things? Harry, what did you do?
For question C,
Yeah.
I cube root 27.
You mean from the question here? Cube
Yeah,
root 27, like that?
yeah.
And then?
And then I squared it, the
And
answer,
square, yeah.
and then I put 1 over that because it's negative.
So 1 over, yeah.
Yeah.
And then?
And then 27's cube root is 3. And then 3 squared is 9, so 1 over 9.
1 over 9. Okay, okay, very good. Okay, that's correct. So because we learn negative exponent first, right? So usually the way I would do it is I take care of the negative before I worry about the root, the radicals. Okay, so the order I would do this is I will flip it, right? Because it carries a negative exponent. So I will do the flipping in the first step. I bring it down, and then negative 2/3 will now become positive 2/3. And then because 2/3 means having a cube root and a square, so I rewrite it like Harry's did, right? Or Jenny, right? Both the same. So the Jenny's answer here is for radical form. Okay, this is called radical form. So if the question says, please leave your answer in radical form, that's it, okay? You stop. But because this one it says evaluate, so you got to do 2 more steps, okay? You find the answer for cube root 27, which is possible, right? It becomes 3, and then 3 squared, then you get 1 over 9. So that will be the answer if it says evaluate. So that means evaluate, when you see the word evaluate, it means your answer has no exponent. That will be the rule. Okay, your final answer, you cannot see any exponent. So if there's exponent, you got to either put it into radical form and evaluate, right? Or square that, right? Cube that. Okay, you have to use up your exponent. Okay, so please differentiate the 2 different answers. Okay, one is called radical form, one is evaluate. Okay, let's look at D. Okay, what's your answer look like? Can I have Angela? What's your answer?
I got root 4x. Or like, wait, sorry, I don't know how to say it. Like, yeah, and then inside 4x.
4x. Okay, so we have a square root, right? This one is square root 4x. Does anyone have different ones? Does everyone have the same? Yeah.
I got 4 over the root of x.
Okay, 4 over root of x. Okay, that looks very different. Yep. Okay. Anyone else want to add to the list? Anyone got something different? Selena, what's your answer look like?
I got 1 over 4, like root 4 over x.
Root 4x, like that?
Yeah.
Oh, okay. So you have a third kind of answer. Let's see if we can get a fourth one. Waylon, what's your answer look like? Does it look like any one of them?
Got the second one.
You got the second one. Okay.
Yeah.
All right. Thank you. And how about Marcus? What's yours look like? Marcus?
Oh, for what answer I got?
Yeah. What answer do you get?
Oh, I didn't finish this one.
What do you think the answer should be?
Uh, I don't know.
Okay, let's go over this together. Okay, keep your mic on.
An answer.
Yeah, Ivy. Yeah.
I got 4 radical x over x.
Oh, like this?
Hmm.
Oh, okay. Right. So, Marcus, right? Here we have an exponent, right? What's the exponent here?
Negative 1 over 2.
Okay. And what do you think is the base for the exponent? Base.
4x.
4x. Okay. If the base is 4x, then there should be a bracket around the 4x. Then the 4x is the base. Because there's no bracket, so the base for that exponent is only x.
Oh,
Okay, does that make sense?
yeah.
Okay, so the negative 1 over 2 is only affecting the x. Okay, just having no bracket make a very big difference. So what does negative exponent do?
You gotta change it. I don't know. You like change it to positive.
And how do we do that?
Um. You gotta flip it.
Yeah, so let's flip it. What would it look like then?
Would it just be 2 over 1?
Oh, you don't flip the exponent.
Oh. 1 over 4x.
Don't touch the 4. 4 has nothing to do with it.
1 over x. And then to 1 over 2.
Yes, okay. So you bring the whole thing down and then make the exponent positive. Okay? And then the 4 is just waiting on the side because 4 has nothing to do with the exponent. Okay? The 1/2 is only affecting the x. Okay, let's continue. Okay? What does x to the half look like?
So you square root it.
Yeah, so it becomes,
Square root of x.
yeah, so 1 over root x times it by 4. When you times it by 4, it's same as 4 over 1, right? 4 is like 4 over 1. So if you multiply top times the top, bottom times the bottom, so the answer should become this one. Okay? So I think it was Ivy, right? Ivy's answer is this one. This one had, how did you get that one?
Oh, I don't know how to explain this.
Well, what did you do?
I did.
Huh?
Uh,
Like, did you get the 4 over root x and then becomes your answer? Like, is there something you did to make it into that?
Like I did 4 times 1 over,
Let's say that one more time.
like I got 4 times 1 over x to the 1/2.
4 times 1 over x to the 1/2.
Hmm.
Yeah.
And then it becomes 4 over x to 1/2, and then 4 over radical root x.
Yeah, yeah. So
Yeah,
far agreed, yeah.
Why I continue it, and then I time it by root x over root x.
Oh, okay. So you probably learned something before, right?
Mm.
Yeah, okay. This is called rationalized denominator. We haven't got there yet. But then a little bit tricky when you take the square root x times square root x. It will make the denominator become absolute value x. But then let's not get into that right now. Okay, we'll just leave your answer. Okay, you can just leave your answer right now as this. Okay, the one in the box.
Okay.
Okay, yeah. So you're a little bit ahead of us. Okay, all right. So let's take a break first. After the break, we'll try a few exercise. Okay, so you can review if you have questions about this or ask me. Okay, during the break. I'll see you guys at 2:45.